Primeiro, agradecer, Marcelo, por ter topado compartilhar conhecimento. É um conhecimento intenso, assim, que está super no Edge, né? Quase ninguém sabe a diferença disso, de um CCIP, de um Cross-Chain Messaging. Então, a intenção aqui na RC55 é a gente trazer esses conteúdos para quem tem essa intenção, né, de trazer. Às vezes pode ser pela forma altruísta, que você não tem nada claro a ganhar, só compartilhar conhecimento. Às vezes, você compartilhando conhecimento, você entende melhor, você conhece a comunidade, você mostra alguma coisa que você está construindo. Enfim, então obrigado, Marcelo, por ter topado. Vai ficar gravado, que nem os outros encontros. E é isso aí. Hoje a intenção é ser um pouco mais rápido, né? 40 minutos, 50 minutos. E quem quiser perguntar, só levanta a mão ou abre o microfone. Eu vou tentar ficar reparando aí se alguém quiser falar aqui no formato híbrido. Beleza? Obrigado, Marcelo.
Thank you. So we could start, I guess. So maybe I'll quickly introduce myself and like say a few words about the talk today. So, okay, everything is good. So my name, can I get some water maybe before we start with this? So I'm actually like a bit confused. Should I like look at the camera and like treat this as a call or like look at here? Whatever.
Yeah.
I can do one slide walking around and a bit seated. So I'm Marcello, founder of Herodotus. We are like infra company. We do ZK stuff, and ZK stuff, more precisely, what we do is a coprocessor that runs on top of storage proofs. And it's not going to be the topic of today. The topic of today will be intents that do leverage the technology that we built. And I feel like today it will be really, really high level. I want to introduce what intents are, how we went from transactions, like how users started interacting with Ethereum, what were the attempts to like improve it, what are the problems of like using Ethereum, and how this stuff works, what's the stage of it today, and kind of give you like an overview. And if we have enough willingness, we will like get into like some technicalities. But again, the purpose of like this meeting, this workshop, is more to like establish some context and give you like an idea of what intents are, what problems they solve, and basically learn more. And the name of the talk is From Transactions to Intents. I think I don't have intents here, so imagine that we have intents here. What, not how. So we'll understand this title a little bit better. So now let me move on to the agenda. We even have an agenda for today. No. Okay. Oh, amazing. So it's a very high level agenda. Not sure if I'm gonna precisely follow that. My plan is to pretty like freestyle the meeting quite a lot. But the plan is as follows. Give you some overview of what a transaction is, why it looks like how it looks like, what it really represents, how we deal with transactions nowadays. Then I will kind of walk you through the different attempts in history of how people try to solve it in Ethereum, why some attempts work, why some didn't work, how they evolved, what seems to be the consensus today, and then I will talk about how messed up Ethereum is getting with having multiple rollups, doing everything cross-chain, and why seems like the intents are the only solution. And so they're the future. And of course, I have to do the sponsored part and tell you about storage proofs, but I promise to keep it very high level. Awesome. So what is a transaction, first off? So Ethereum is a state machine, right? Like it's a blockchain network with an underlying database. There is a state transition function called EVM, and you interact with it somehow. And we call those interactions like transactions. The EVM is capable of like doing a lot of stuff because first of it's Turing complete. We can save things, we can delete things from it. It's persistent. So those actions that we do with that system have to be like very expressible and very like generalized. And those objects are transactions, and we have to ensure that, you know, they pay the fees, because if we don't pay the fees, the validators don't have incentives to run the network, and so on. There's a lot of like technical nuances that have a very good reason to be there, but it makes the UX bad. I guess many of you, probably all of you, use MetaMask and keep using MetaMask. Not sure how long you've been using that, but if you use that, let's say before EIP 1559, you probably find yourself in a situation where you wanted to destroy your computer because when submitting the transaction, nothing was really working. You had like spikes in the gas price, the transaction was failing and stuff like that. And the reason we pay fees is, again, I said, we need to keep the incentives in the network. So everything sort of makes sense, but the UX is absolutely terrible. And there were like many attempts to fix all of those problems in Ethereum. EIP 1559, maybe it's I shouldn't mention it because it's just going to add some confusion, but nevertheless, I will cover that when I will talk about meta transactions. And one of the first attempts to sort of solve those problems. Yeah, okay, but maybe first thing first, let me set up some context what a transaction really is. So like I said, it's an object that a user signs with his private key. A user on Ethereum is identified by its address that is derived from the public key, and the transaction basically includes who is signing the transaction to. So if it's a simple transfer of fund, the recipient is the recipient of the funds. If you're interacting with a smart contract, let's say ERC20, then the recipient is the smart contract itself. We need to encode what we actually want to achieve, and this is the transaction data, which is basically arbitrary. And wallets thankfully handle that. Hello. Then we have information about gas, so how much compute resources we expect this transaction to consume. I also talk about why this is a bad abstraction for that, and how Intents can potentially tackle some future problems. We have nonces. Nonces is in order to avoid replication. So let me give you an example why nonces are relevant and why they're extremely relevant also in Intents, and everyone who's dealing with Intents has to like think about those. Replay protection. So if you sign a transaction that says, I want to send 20 if Bob signs a transaction that says, I'm sending 20 ETH to Alice, he can submit it to the network. Alice will receive the funds, but Alice can pick up the same signature, submit it again, and we have a double spam. We made a transaction twice. But if Bob is going to sign each transaction, you know, like a counter that keeps increasing with every transaction he does, only a valid signature will authenticate the move of funds. So no one without his private key will be able to do that. So that's why we need nonces. The same applies to Intents, but we'll get there. Okay, let's move on. So how do we send transactions? Wait, let me move on a little bit. Okay, so how do we send transactions, first of all, like most users do? We have wallets that abstract a lot of things away. So they handle ABI encoding what that is. So like I mentioned before, we do have smart contracts. They're Turing complete. They can do a bunch of stuff. And because they can do a bunch of stuff, it's very like generalized, you know? So when a user says, I want to transfer funds, it doesn't say I want to transfer funds. In reality, under the hood, it's an ABI encoded call. So we have to like get the function selector, like compute the, get the function signature, compute the function selector, encode the parameters, like stuff that is really human unfriendly, but is understandable for machines. Of course, we don't do that. It's wallets that deal with those things. And wallets know how to deal with those things because you have underlying JavaScript libraries and a very long supply chain of helper tools. They also handle signatures, dealing with nonces, and quite a lot of things are abstracted away. But still, I'm sure you had that issue with paying gas. You have to think about gas. You have to think, oh, is my gas price sufficient? Oh, is that transaction gonna run out of gas? Because it might if the wallet does the estimation wrongly. So there is a lot of, pains that come from how Ethereum is structured and how you have to structure things on like blockchains capable of smart contracts, of running smart contracts. And some people identified it in the past and thought, well, we need a solution that ideally does not change the protocol. And this is where the slow journey to where we are today started. And today seems like intents are the solution to that. So let me continue. I said why fees exist. Meta transactions. So meta transactions, any questions so far, maybe, before I get into the new chapter? How can I check if there are any questions like here on the from the audio?
I'm checking the chat.
Okay. All good?
All good.
All good?
They are hearing you out. Just if you can remove your blur,
Oh.
your Zoom background blur.
I'm not sure if I'm such a good of an engineer to do that, but let me try my best.
Yeah, you don't.
Maybe now. Oh, I think I made it.
Here. Here.
Yes.
Video. Yeah. Okay.
Yeah, now let me play the slide. Okay, so meta transactions. Meta transactions are like a concept that was, if I recall properly, born in like 2018. So quite old stuff. And the basic idea behind it was, let's try to make the UX better. And back in the days, the biggest pain point was that users have to pay gas. So you have some, let's say USDC in your wallet, let's say 1,000, you think, oh, it's a lot of money, I should be able to transact on Ethereum. Then you want to transact and you see, oh, shit, I don't have ETH, I cannot pay for gas, such a bad thing. And the apps are like, oh, maybe we could sponsor like transactions fees for our users. And everyone's like, hey, how can we achieve that? There were some methods and some ideas, and one of them was like meta transactions. So to recap, the first motivation to even come up with meta transactions was the problem, can dApps pay gas on behalf of users? That was like the initial idea, how can we get there? And the answer is yes, they can. At least they could back in the days, but this design didn't work for like many reasons that I will cover today. And the next thing was, can users pay fees in maybe some other tokens, like let's say USDC? So basically there are like two problems to solve. First off, can dApps sponsor gas on behalf of users? Secondly, can users pay transaction? Can they interact with the network paying with a different token and kind of like passing over the responsibility for, paying for compute and storage in ETH to someone else. So how was that actually solved? We introduced a concept called meta transactions, which is quite similar. It's again an off-chain message where you say, I am willing to interact with that contract. This is the data that I'm gonna send. This is like how much USDC or something I am willing to pay for. This is the guy who I allow to forward my transaction to the chain. We'll get there in a second. And a bunch of other parameters, of course, nonsense, because we want to avoid duplication and replaying. So here the story is pretty like simple. That's why it was called meta transaction, because it's an object that is effectively like simpler, because we don't have to think about how you pay for stuff and gas and all of those things. And what happens, we take that off-chain message, we send to a guy, and that guy will eventually send it to the validators, right? Back in the days, miners, and include that in the block. And those guys were called relayers, and they were the ones that were facing directly the chain. So there are some issues. First off, you probably can already identify what if the relayer censors you. So that was the first issue with meta transactions, that things were getting quite centralized. The UX was still like weird, and you could not achieve really complex things such as you can with intents. Such as imagine using meta transactions in the cross-chain context, that would be pretty complex. Also, the smart contracts that users interact with had to be aware of like what meta transactions are, which already makes it way more complicated because developers have to like think about it and be like, oh, is my user just gonna be, a regular like wallet? Is he gonna interact with like meta transactions? It was a lot of pain, to build those systems. So, but the UX was sort of achieved. Any questions so far on this front? Maybe from the audience as well. Okay, nope. There were issues. Biggest one was censoring, and how do you make sure that the relayer does not censor you? And this is why the gas station network happened. The gas station network was an initiative, I think, started by some folks from the EF, Open Zeppelin, and the gas station network itself. There was like an entire bunch of VIPs around it, an ecosystem. And here the idea was, okay, we can have another network, a layer on top of Ethereum, where relayers, can discover themselves, like users can submit to different relayers. We can sort of ask what would be the execution price. So you can say, oh, I'm gonna pay for this transaction USDC, but how much should I pay? You could ask a relayer. Different relayers could, compete with who's gonna execute it at a better price and stuff like that. So, we sort of rebuilt the dynamics of transactions, but we sort of added like this layer of abstraction on top of it. And we also had paymasters. So standardized paymasters. This is important. So paymasters is, again, this idea, like I mentioned at the beginning, that dApps can pay fees on behalf of users in a standardized way. So what was really achieved thanks to those standards, you had like a bunch of libraries available in Open Zeppelin that were supporting gas station network. So maybe let me ask a question to everyone, also to the audience. Who writes Solidity and for how long have been writing Solidity? And if you wrote it long enough, do you remember this weird thing in Open Zeppelin? You had a helper function underscore message sender instead of calling message sender directly. No one's using that today, right? Why? Because this is dead. Everyone forgot about it, and that was one of the attempts, to standardize it and imply that standard on everyone. And that was exactly to achieve paymasters and having users that, can pay like whatever, potentially not even pay for transactions and stuff like that. So that was the gas station network. While people were like testing that and, implementing and applications were being built on top of that, some folks actually realized, hey, what if we abstracted even more? And then account abstraction happened, and ERC 4337. But before I get to that, let me talk about the gas station network and like a high level diagram. So like I said, there was the transport layer, access and accounting, and application layer. So the idea was that a client, like a MetaMask account or whatever like that, should I stop to have more people coming in? Okay. Like a shit, we need more people to listen to. We'll gladly wait for you. Okay, so what I'm explaining here is sort of the flow of what was happening with gas station network. One of the first attempts to implement meta transactions and standardize it. So we had a client, usually a browser, that had a specialized provider, was signing an off-chain message that represents what smart contract we want to interact with, how much you're willing to pay, like what token, etc., etc. Some things that a normal user would not really understand, also ABI encoded transaction codes, blah, blah, blah. Cool, we have that message, we send it to a server, meta transaction relay server that would submit it to like a bunch of relayers potentially. So sort of like another layer on top of like RPC, kind of the same thing. And there was also like a concept of a mempool. Then once that off-chain message is sent, the relayer, so a specialized actor, what he would do, he would take that off-chain message and send it directly to the chain, back to a specialized contract called, a contract that has the paymaster functionality. So the relayer would sort of like somewhat trigger the move of funds towards him that would, reward him for executing that transaction. That was sort of the flow. But like I said, the contracts that you were implementing had to be compatible with gas station network. This is also why back in the days, Open Zeppelin libraries had this like weird underscore message sender. That's exactly like a relic of these times. Any questions on that, on gas station network?
Why didn't this model pick up in the end? Why there was an adoption with from the devs?
Because account abstraction kicked off.
Okay.
And actually, what is funny, ERC 4337 is a standard mostly developed by the gas station network folks. I think it was called OpenGSN at some point. Started. Oh, hello. So here the objects got a little bit more fancy. Everything was like leaning towards how can we represent more. And user operations appeared. So another fancy wrapper on top of transactions and expressing what we really want to achieve and how we want to interact with the chain. We also replaced relayers with bundlers. We still had paymasters, and most importantly, programmable wallets came in, where you could decide even change stuff such as how do you authenticate transaction, because probably what you've seen so far, every single action was being authenticated with me taking my private key and signing a message. But account abstraction enabled things such as you do, let's say, on WordCoin, on the Word chain. Every single account on that chain is an account abstraction account, and you can authenticate a transaction with your face or your eye, whatever. So that was already like a huge UX improvement that was not possible with the previous infrastructure. So biggest use case of maybe biggest application of ERC 4337 so far, I think, is Word chain. This is the chain where literally every account functions like that. I mean, every account that is connected with Word app, because you can use also MetaMask if you wish. But yeah, this is the best solution in terms of UX so far there. But here the architecture changed a lot, and a lot of standards had to be made. So let me walk you through that. So similarly to meta transactions, we had a user that needs to be aware of what he wants to do. Let's say send a token. So he's interacting with a contract. We do the usual stuff such as encoding the call, somewhat signing that with, like I said, maybe SecPK1, maybe something else. Here it didn't really matter. That object that represents an action was renamed from transaction, meta transaction, to then be a user operation. That was going to a specialized mempool from which bundlers could pick up. Bundlers could pick up multiple user operations, send such a bundle on chain, and then all of those account abstraction wallets were basically checking, oh, is this user operation valid? So by checking if it's valid, we have to verify the signatures, we need to verify the nonces, we need to call the contract that we actually said that we want to call. We need to ensure it doesn't fail, but if it potentially could fail, if it fails, we still need to pay gas and stuff like that. So that entire validation was happening. One more advantage that this construct brings is that you have bundling. So you can potentially allow users to not even pay for transactions because I don't know if you guys remember the MEV times, but before EIP 1559, it was very common that you could transact with Ethereum and like swap some tokens on Uniswap without paying for gas, because basically you're paying with slippage and you're allowing someone to like just sandwich you, and that's how the payment was made. Why I'm saying that is because you know, here we have bundlers, so so it's like another layer on top of block building, and those bundlers can, for example, not charge you at all, but they will like do some MEV on top of your transaction, very likely positive. So good stuff, which was not really possible. It's not possible with normal transactions. What more? A hot topic was BLS signature aggregation. So something that is done constantly on Ethereum. Every time you submit a transaction, meta transaction, or whatever, you verify signatures. But thanks to the standard, you can identify an account by, let's say, a different signature scheme. So you can sign with BLS instead of like PK1. And BLS allows you to do signature aggregation. So, you know, on the blockchain, everyone is storing everything forever, and signatures are quite big. If you multiply them by a couple of millions or like tens of millions, it's a lot of data to store. So if you bundle it and you have, you know, one aggregate signature for many people, all of a sudden, you know, running a blockchain node is just cheaper. So that was also like the motivation, you know, like thinking forward how Ethereum should look like. So here things were getting really, really interesting. But again, the problem, in my opinion, I wish the best to those standards, is that it still imposes a lot of things. And this is sort of where intents started to like kick off. Like, you know, people zoomed out. Maybe there's something more to do here. So let me stop maybe for 30 seconds. Any questions?
With this architecture, the problem that you used to have with, I need to first approve something and then execute.
Oh, that's actually a very good point that I missed in both meta transactions and gas station network and this. What you can do, you can like sign multiple things at once. Because like, look, today, if you just do things normally, you want to swap some tokens on Uniswap, what do? You first approve, and then you only swap. So you interact with MetaMask, you have the pop-up twice. We're used to it, but for like a normal user, it's a mess. It's like, it doesn't make any sense. In this architecture, you just sign 2 user operations. That's it. And you submit them to the bundler and he executes it. So I'm not sure if that answers the question.
I need to, in the end, I still need to sign 2 times, or can I sign one big?
You can sign one big structure, yes. So you could batch it. So here already, you know, applications, like when you're building the front end, like think on the smart contract, you could already like think about those things. Oh, I can batch multiple things together. That's already like a huge UX improvement. Yeah, any more questions? Okay. Here I might be lying, but all of those efforts started more or less 2021, 2022. So still the era before when rollups were just like kicking off and Ethereum started to be fragmented. So a new problem appeared. The new problem being fragmentation and people interacting with Ethereum in that way that you had like MetaMask, but you had like assets on like, I don't know, Base, Optimism, Arbitrum, and Ethereum. So things were getting messy again. And the solution had to be found. So we made a full circle back. Hey, what if we sign messages off chain? We have like some other guy who's like executing things on my behalf, but now it's 2 chains at the same time. And sort of intents are like kicking off again. Maybe as I'm sort of freestyling that talk, I want to mention what, in my opinion, was the real first implementation of intents in Ethereum was 0x protocol, like an exchange. I don't know if Anyone use it here? Okay.
Limit to orders and
Yeah. So basically the idea was that you're sending messages, you're sending things to their backend, they're doing stuff, and then if a match was found in the order book, they submit the two signatures on chain and the execution happens. Quite nice. And that was like 2017, 2018. So really ancient times. And we made a full circle. That was, in my opinion, one of the first implementation of intents. Okay. But now with those challenges, we had to sort of zoom out again and think what the user actually wants to achieve. Not like, okay, he's calling like this function and with those parameters, like we actually have to zoom out. Because you already introduced, a specialized mempool. So we had bundlers. We already zoomed out like paying for fees that was already abstracted. You could pay with multiple tokens. So what if we can sort of create intents that are even application specific and change our architecture completely? So we went from what you want to do, not to how you want to do it. And that mental model switch already allows you to, not think in terms of like one chain, but like multiple. We can think about the actual outcome that my application wants to give to the user. So I feel like this is like the most important thing when reasoning about intents. But they also have their challenges, and I will talk about it. So to zoom out, like one more time, we have a new actor called solver when it comes to intents. So today, the protocols that heavily run on intents is first off CowSwap. I'm sure almost everyone knows CowSwap here. 1inch, Uniswap v4, if I'm not mistaken, v4, and something else, but I will mention that later. So that was like the switch. I'll talk a little bit about CowSwap. So the original promise of CowSwap was removing MEV. CowSwap, to remind you, allows you to exchange one asset for the other, basically swaps. And the eternal problem of AMMs was that you have slippage. So again, one more parameter that the user has to think of, when in reality, what the user thinks of is like, oh, I want to swap my USDC for ETH. And that was like causing MEV. So people, what were they doing? Like you had guys that were like watching for the mempool and seeing, oh, Dina submitted a transaction. His slippage is, let's say, 1%. So that means he's willing to accept a price that is potentially not benefiting him to the threshold of like 1%. So what they were doing, they were basically selling or like buying an AMM, manipulating the price so you pay the worst one, then arbitraging you.
1% slippage only is there like people rolling like 10% slippage.
Yeah.
Right, to like some tokens.
Yeah. Pretty bad stuff was happening, but CowSwap thought, okay, what if we have like a separate mempool for things related to swapping tokens that sits like on first our server, then we would somewhat decentralize it. We can have a coincidence of will situation. The abbreviation is COW, so cow, so CowSwap. And we can see, oh, one guy is willing to sell, another guy is willing to buy. Oh, what if first, they sort of do it peer-to-peer, and then the remainder of that order, we match it against a Uniswap pool or something like that. Oh, and who's going to do it? Solvers. So solvers will take that order flow and see what's the most optimal execution path. So that's sort of, where intents go. We simplify things from the user. We introduce a new actor who's taking care of like optimal execution. And those guys are called solvers. So they basically compete for the best fulfillment and the most optimal path. Why? Because then they can extract the fees effectively from the user. And they can compete for the right, then execute and collect those fees, which again, those economic incentives to find the best paths for those users. Any questions so far?
I don't have a question, but the way you phrased it, it kind of like led me to think that intents took the bad behavior of MEV and then put it into solvers, so made like the bad actors legit actors. But that's not a question, but very well. Okay.
Good. Let me move on. Maybe there's something else that I wanted to say. Okay, so again, we always have the same issues as with transactions. We need to make sure that replay is not possible. What are the ways to prevent it? So a stateful way. Stateful, I mean, requires maintaining some state on chain and sort of remembering how many actions have been done by the user, which is nonsense. So here, the annoying part is that if you have a system that runs on intents and you probably have a smart contract, your smart contract needs to keep track of nonces per each off-chain message that you sign that represents that intent. That's quite annoying. Another possibility is like introduce deadlines. So you're saying that that signature is valid only for, let's say, 60 seconds. And if the contract verifies that signature after the deadline, the thing is not valid anymore. So you could replay it, but you have a time window, maybe you can apply both and stuff like that. And then that contract of yours has to mark it as executed and sort of like nullified, consumed, whatever. So why I'm saying all of that is because with intents, you're really like as a developer taking a lot of responsibility, because you're not letting the chain itself and set the rules of how users interact with your system. You're sort of taking that completely. You can even say, okay, I don't want people to have wallets. They can like authenticate their actions however I want, right? So, and then you can like submit this on chain, and you really like change the mental model here. Yeah, I want to mention about the YDX, but I think we can talk about it a bit later. Okay, so where we are today. Today we have another complexity, which is cross-chain stuff. So let's say I wanna bridge some tokens. I wanna move them from base to optimism. It's gonna be like multiple clicks, because I have to like click first approve on base. I have to click like bridge, which is one additional transaction that is gonna take my tokens on base and log them into some contract. Then I have to wait for the cross-chain message if we use the canonical messaging bridge to notify one chain that the funds arrived. So I have to wait. I'm getting really nervous. Then I have to open MetaMask again, switch the chain. Oh, but shit, I need to import the RPC. So I go to like RPC list. I check, oh, okay, the RPC of Optimism is, I don't know the RPC, but you see what I mean. Oh, I also have to check the chain ID and stuff like that. And then it happens, oh, I don't have any ETH on Optimism. I cannot pay for gas fees. It's terrible. But I somehow got some ETH on that chain, and I can finally, claim back my funds. Congratulations. It took me a lot of stress, a lot of time, and a lot of money and frustration. But some people thought, what if we have guys who actually take care of the execution and will just front that money, and the guy just signs a message that will allow to pull his funds. So, here, again, you're signing an intent, how you do it, let's say, on a cross or another bridge that I'll introduce called Most. Again, you zoomed out, you build the system of authenticating user action that is very specific to your application. And that works in the cross-chain context. And you can represent stuff such as, oh, take my money on Optimism. I will have a solver that will take that money and maybe even do a cross-chain swap, right? Like it's gonna give me ETH on the other side. Or I can do some crazy stuff such as I do on, let's say, Bungie, where I'm spending USDC on Optimism, on base, and I'm getting on Optimism ETH and USDC, because I also wanna have a little bit of the gas token. So you see more stuff is available because we zoomed out and we sort of delegate the responsibility of finding the optimal path to external actors. Any questions on that so far? Okay, good. There is one more complexity, a lot of them, but in the cross-chain context, we also have settlement. So coming back to the original example where I'm using, let's say, the canonical message bridge to inform one chain that the funds arrived, is settlement. Like we have to wait until that message arrives. But if you use a bridge such as a cross, it's almost instant. How is it possible? Well, you have a guy who basically takes on the risk. He sees that you lock the money into a contract on Base, and he's gonna front that on the other chain for you. And he's waiting for the settlement. He will, wait until Base settles back to Ethereum. So that message can be propagated to Optimism, and we can get the funds on Optimism or the other way around, whatever. We introduce like another layer of abstraction, and we defer the settlement. So this is something that is achievable only with intents here, only. And this is sort of, where the UX in Ethereum, is going. Any questions?
I will always need kind of software that is listening the events in the chains, right? Because when I submit a transfer from chain B to chain A, I will trigger a kind of event telling you I wanted to transfer this value to chain A. And I need a kind of a software that is listening to the events. There is no other way, right?
As a user, why do we need?
I don't know, somebody, a third party, a trustworthy third party. Nowadays, for instance, CCAP, this trustworthy third party is the chaining, for instance. But for instance, in Polygon, if I want to send some NFT or send some stuff among Ethereum and Polygon does this as well. Is listening and make transfers among Polygon chain, POS and Ethereum. They have a software that is listening their smart contracts events.
Yeah, let's say the bridge provider,
exactly.
they need to have that software.
Yeah, so for this is something that there is no other way to.
Yeah.
I always will need this.
Yeah,
Okay.
yeah.
Okay.
But the user, he's happy because one click.
But that doesn't the software get a fee in that case? Isn't that the incentive to run the software?
Because
I mean, they have access to the order flow. If they have access to the order flow, they can capture those fees. And have access, they need to listen to it. So yes.
Because before the start of the session, the discussion I was having with Robinson is that nowadays the problem is each provider has their own signature or their own steps to do this. The breeds, they have their own, a math standard methods or standard events names, blah blah blah. If we have a single standard, that like okay, I have my chain, I have my bridge, but I follow at least the same name. Everybody follow the same name as a developer. This will make my life easier, Like we have a RC20
Yep.
1155, but everybody follows the same name. At
It's-
least this will it starts to make my life easier, as a stability developer.
It's a good point that you're raising. I don't have this covered in the slides, but there are actually standards being developed around intents. Let me phrase it politically because I have a strong opinion here, which I don't want to express. But there are some standards being made because indeed, as a developer, from your standpoint, it's gonna get really messy with those architectures sort of like taking off. But in my opinion, I think I have to express it. We are sort of doing a full circle, you know, and getting back to like the GSM days, trying to build a standard around it that will like break again. No one's gonna follow it. But anyways, some work around standardization is actually happening already in the intense ecosystem.
Do you know the Optimism superchain interoperability protocol? Is that like one of those standards? Because it's the one that's being built right now.
It's a little bit unrelated. I mean, it is related because, you know, when it comes to intense nowadays, when we build systems that utilize intense, it's usually crushing intense, because this is like the biggest problem that we have to solve nowadays. And every intense system has two things that are kind of sort of like extra and special. We have solvers and we have settlement logic. And that settlement in that case is cross-chain. And within the super chain, within, you know, chains that are like part of the super chain, we can have like some communication protocol that allows for like faster settlement. So it's a little bit unrelated, but it's work that, let's say, can facilitate settling intents between base and optimism.
Previously, you mentioned about across doing like very fast swapping thing because someone else is willing to take the risk, right?
Yep.
What is this risk specifically that you're talking to? Reorganization of the blocks?
Yes. And to potentially not settling, like reorganizing transactions and not settling back to the base layer and stuff like that. By base layer, I mean the L1.
The original one. Yeah.
Yeah.
So like I pay you, I as a solver, I give you the money, but the money that I was going to pick as the payment is reorganized.
Yes, exactly.
So the risk calculation that you need to do is like the probability of reorg of your origin.
And look how crazy this is getting. Like as a solver, you're becoming really fancy because you have to understand how the L2 actually works. What are the risks involved? When is it gonna settle? You're like, oh, Optimism will probably settle to Ethereum in an hour, so my funds will be stuck for an hour, and within that hour, I could take that money, put it on Aave, make some yield, so my effective cost is this, and this. Like it's really, really complicated, you know, to price those things. But from the user perspective, just an intent, you know, and then there is like some specialized guy that is gonna price it, execute it, and so on, and eventually even settle this with the base layer. I think I'm gonna continue with the slides. So now I have to mention about it because this is like the work that I've been doing for the last 3 years. So it feels really bad not talking about storage for a little bit. So today the world is becoming fragmented on Ethereum, and settlement is crucial. Storage pools are like a very funny cryptographic construction that is possible on like stateful blockchains such as Ethereum, especially blockchains that merkleize the state and every block comes with the root of that state called state root. It is possible to prove that something within that database existed or exists. Based on that, you can do settlement. So every chain that is a rollup to Ethereum, such as Optimism and so on, follows the same construct. What you can do, you can generate Merkle proofs that say something happened or like something is present in the state or it was present, and you can basically use those statements on the other side and execute the settlement, right? You can do even crazier stuff. You can compress it into ZK, and you can, you know, compress multiple settlements at the same time and access multiple storage slots, access multiple events, multiple actions, and so on. And then one proof can potentially aggregate facts from multiple chains, because you can have one proof that says this happened on Ethereum, this happened on Optimism, this happened on Arbitrum. So look, even though I'm a solver, I pulled money from, let's say, multiple different chains from that user because the user had like funds everywhere and he wanted to receive it on, let's say, Polygon, but he had 10 USDC here, 10 USDC here, 10 USDC on another place. He signed one thing, but they do the settlement, you know, in one go. So this is like what storage proofs effectively enable, what you could potentially build with that. And yeah, we have that tool that enables efficient settlement. So wait, I didn't proceed with the slide. So with what we built, one can build on top of our stuff systems that utilize intents and sort of access cross data as well as historical data. Why historical data is even relevant in intent. So I think I had a slide about CowSwap, or it's the next one, but I have it here. So on CowSwap, solvers like get reimbursed. Also, when it comes to bridging, once a solver proves that he fronted the funds, and when he proves that, he settles things that happened in the past, right? So he has to access historical data. And again, the only thing that gives you access to this historical data from a different chain is like storage proofs. So those architectures are actually getting really relevant in today's Ethereum. And it's becoming like possible to even build that. But also I can, for example, prove that I'm the best solver. So I'll get access to deal flow, or I will collect fees. I will collect like more of them, or I can, make some faster settlement and sort of like have some follow different rules in the protocol than other untrusted and unproven solvers cannot, because I, had a good track record or stuff like that and reputation. So this is sort of what we're doing and what's our contribution into that ecosystem. And now to maybe getting towards the end of my talk, but I would like to first talk about like the stable a little bit. So there are, like I mentioned, a couple of applications that do utilize intents, and they differ quite a bit. I mentioned like the 5 I'm the most familiar with. So CowSwap, I think the most popular one, Uniswap X, 1ETH, and 0x. Who is getting paid? So who's the guy who gets paid by the execution? As you can see, the name is different for every single one of them because there are no standards yet. Some are being developed, but no one is following those. They play sort of like different roles. They do execute some MEV. They sometimes find the most optimal path, but very often they also execute it, and they do both things at the same time, and they also hedge it, and they do a lot of like weird magic in the middle. They are rewarded like differently. Their payout is also different. The way gas is paid also differs, and there are like different constraints. So like step out and allow you to like make a picture if you want. And I think that I'm getting towards the end of the talk, and happy to like engage into like a conversation, discussion, and answer any questions. Yes.
Do you think there is a way that solvers can hedge against the settlement not happening essentially?
Yes. So there is some risk. Like I said, let's say you're a solver for a bridge, a market maker for a bridge. What could happen is that you front-end the funds for the user, and then the L2, let's say, I don't want to name any L2 that would do that, but let's say there is a new L2, completely untrusted, an optimistic one, and they say, oh yeah, I'll give you this pre-confirmation, this transaction, it happened, and then be like, this transaction didn't really happen, and as market maker, you paid out your funds, and you won't be able to like execute the settlement because that chain did not settle to the base layer, so you cannot even initiate the dispute mechanism, whatever. So yes, you're taking some risks because the sequencer can like mess up with you. Do they hedge against those things today? No. Is there a provider for that? No. Like there's no liquidity on those markets, but it would absolutely make sense for them to hedge against such events. And if they have to hedge it, and hedging always comes with a cost, users who will sign such an intent, they will like pay the price for it. But again, they have no clue how to price it, but solver would do.
So the provider would like, let's say, distribute the solver itself, let's say 100% of the risk to the, let's say a couple of people, for example. So it's like risk distribution.
Yeah.
Okay.
Yes.
In this table, you are not mentioning, at least I don't know if they are, but they are not known as bridges, like across, Bloom, or Wi-Fi, like those guys. Why you didn't, just coincidence, or they're not doing that?
No, no specific reason. I just focus purely on like swapping and stuff like that because there is like more MEV involved, more MEV dynamics, and I really want to talk about the MEV dynamics today. So that's purely the reason. Yeah, and we also have like Dutch auctions in many of them. The reason for that is to reduce that MEV and create like different dynamics. So yeah, no specific reason, but intents or today the architecture that is used, I think mostly dominantly in like bridging.
And I saw that some of those bridges, I don't know about those places, but you have permissionless solvers. It's not every bridge that you have like, why?
So very often there are some like assumptions that were made where a solver could censor you or like could give you a really bad price and could mess with you. So we probably want that solver to have some stake. So if we prove him some misbehavior, we can like slash him. So I think that it was 1 each. Yeah, in 1 each you have to lock up some tokens and basically stake. And the reason for that is that if you misbehave, you will get punished. So yeah, that's why often you have to like sort of whitelist or like whitelist once they stake, stuff like that.
Another question that I had is, so as Jeff mentioned about like the bridge providers, so nowadays, do we have a trustless bridge model?
There is a model. I even have a diagram. I'm gonna shield sort of my bags again. So with Herodotus, we're working with a bridge called most WTF, which does have an architecture that is like fully trustless, and they use storage proof for settlement. For the most part, I'm thinking how to phrase it, because I'm biased and I being recorded, so I have to be like very political the way I say things. But the biggest bridges nowadays are not like fully decentralized. There are some trust assumptions being made. And there are reasons for that, right? Because trustlessness and decentralization is something you have to pay for. So let's say if you have a settlement mechanism that is like fully trusted and you have like just an oracle, let's say Chainlink or like something different, like it's gonna be way cheaper, right, than generating the proof. So that means that pricing in such bridging solutions is also gonna be more favorable, but as a user, you don't have such strong guarantees that you're getting, let's say, the best price or your money will actually arrive and stuff like that. Someone can mess with you. Or potentially if you're a liquidity provider who's providing liquidity to facilitate those like swaps, you might be taking a lot of risk, right? Because if the oracle misbehaves, like you're screwed. Yeah. Some other like applications of intents, something I'm personally really involved in is cross-chain lending and borrowing. That's exciting. Portfolio management. So you could build an intent-based system where you say, I want to have a portfolio that is, I don't know, exposed to a specific class of assets, and you just allow external solvers to like rebalance every so often. So you say 40% of my portfolio should be something with this level of volatility. So if some asset within your portfolio gains value or like loses value, this balance is gonna change. So you could have a solver that sort of does that rebalancing, and on your behalf is gonna execute some swaps and stuff like that. Like there's a lot of designs that become possible, and you can even have subscriptions. So something that was completely not possible is still not possible with standard transactions, because every time you make an action on chain, you have to click. But with intents, you can just sign it once, and then someone's going to take that signature and be like, oh, hey, in the past, you actually allowed this thing to happen, and now I'm executing this on your behalf. So you could have some pre-balancing things. You could even have subscriptions, so you pay like every month or something without clicking, because you just take the signature of the guy and stuff like that. So the conclusion I want to say is that the way we do interact with the chain is really changing today, because we're not interacting with one chain anymore, and the user patterns are like changing a lot. And happy to answer any questions now.
Could you go back to a slide where you have a kind of flow? Yes. No. Yeah, that one. Could you explain again this? Yeah. In detail.
So this is how the bridge works. So what happens is that, let's say, bridge USDC from base to optimism. Do we want to make it complicated and make it a cross-chain swap, or just like a simple bridge? USDC to USDC or USDC to ETH?
USDC to ETH.
Okay, amazing. So what I do as a user, I would first call an API and ask some solvers what they're able to offer. So I say, hey, I have 1,000 USDC. How much ETH can I get on the other side? You'd get a bunch of like different quotes. Once you find a quote that sort of satisfies you, you're just gonna take your money, lock it into an escrow contract, and your money is locked. The guy who's like constantly listening for events, and the guy who give you that price will see, okay, you locked the assets, so let me fulfill my obligation and take that ETH and put it in your wallet on the other hand, on the other side. You as a user, the whole flow is done, you're happy, you got your ETH, but then there is the other part, which is the settlement. That guy that fronted the liquidity has to generate a proof that he did it on the destination chain, take that proof, show it to the escrow, and unlock the funds.
Yeah, because I used to work for a protocol called Panther, and in Panther protocol, we used to work to build something similar. So when you deposit here, you create a kind of, you receive a kind of receipt, and we generate a proof that you receive. You deposit kind of asset in a kind of AMM, a pool, and then okay, we have a micro proof here, and then on the other side we have a kind of some micro trees that we have a kind of macro forest actually, where we sync this macro forest across the chains. And
settlement is a really tricky part of like the synchronization.
Exactly, because we have to sync across chains, and a single chain was a kind of leaves. The macro roots of the chains was the leaves on this macro forest and the leaves when I have a user take this proof here to another chain to withdraw the funds, I send the proof. I calculate the leaf decided of the side of the macro forest, and I release the funds. Because of course, time to time somebody needs to check the balances, rebalance the funds, to have enough balance in different chains. But this is what you presented is something kind of similar.
When was that protocol built?
2023.
Okay.
I think they still, I don't know if they become live, but you can check. This is Panther protocol, if they know. Was very audacious at that moment, but was very interesting. They're following what you're mentioning, but it's very, I think what do we felt that we're missing a lot was this kind of a standard of that's something that should be, for instance, the community of oh my goodness, not Solana, the other blockchain, Polkadot. Polkadot, they have the protocol to exchange a message across the
parachains, right?
the parachains. X, I forget the protocol. X. It starts with X.
XMTP, something like that.
Yes, XMTP. You know, I think nowadays it's starting to Ethereum to have something similar. You know.
It's fun. Yeah.
Yeah, we
do
need to
too.
because nowadays everything is based on a layer and different. You know, we have a Ethereum, like a settlement layer, and we have I don't know, several different layer 2 networks. We need a standard, you know, for standardize the names, the protocol for to exchange because it's terrible, you know. Okay, now I need to optimism. I need to do this way. Now with the I don't know, read with this CCAP, I need to do this. Now with the I don't know, nowadays with the circle.
Yeah.
Other things.
I do find it really funny that Polkadot sort of spinned off Ethereum, and now Ethereum did exactly what Polkadot did.
Yeah, exactly.
They started with staking. Oh, shard. Oh, wow.
Yeah, exactly.
Consensus layer. Oh,
Yeah, and the risk V. And
yeah, right.
Exactly. Yeah, the point is the doctor, I forget the name, Devin Wood. He is the guy.
Yeah.
And the problem is he is not politician. That's he doesn't have patience.
Well, another Ethereum co-founder called Hopkins, the Cardano guy. He's a Cardano character, yeah.
Charles.
Yeah.
CJ Chuck. Yeah. But I think but Gavin Wood is great.
So one question regarding those comments. In the settlement step, when you generate the proof and you did the transfer to the destination chain, I need to verify that back in the origin chain, correct?
That's right, yes.
Yes. Okay, so in order to verify this step, I would need to know the Merkle root of the destination. Like I still need to connect like all the origin chain is going to know that this proof that generating the destination is really correct. I wouldn't need like an oracle of Merkle.
Oh, I love that question. I love that question. I feel like I should make another talk about storage proofs. But here the magic is like storage proofs. So basically it's a combination of we leverage how blockchains are built, especially what's the Ethereum architecture today. So if you think about it, what happens is that you have a bunch of L2s that settle back to Ethereum, right? Eventually. And they will post the state root somehow. So if you can access the block hash of Ethereum on an L2, and you can, because you have the canonical messaging bridge, or you can verify a consensus proof. So if you just run a live client on the destination chain, you can sort of access the commitment of those other layer 2s, and you can decompress them cryptographically and access the information about what happened there. That's sort of our like contribution to all of that. The main contribution also.
So you already have the information
Yes.
in layer 1 or the other
Yes.
layers.
Yes.
But if you are bridging from an L2 to another L2, do you still have this information in the?
Yes, because that one L2 were initiated the bridge, like the bridging operation, will eventually settle to layer 1, because otherwise it wouldn't be an L2. But the guy who's like taking risk here is the market maker, the guy who's gonna front the funds on the other side. If that L2 decides not to settle for some reason, he won't be able to unlock the funds from the escrow.
Perfect. Yeah. And for chains that the finality is like a week, is a lot of risk.
Yes, yes. Especially if you're doing like a cross-chain swap, because imagine you're facilitating a swap from like USDC to ETH. So as a market maker, you're effectively selling your ETH to the guy, and during that week the price of ETH went up. You will feel bad. But you can be a smart market maker and like, let's say, buy that ETH on an exchange and be like delta neutral. And it comes with like some risk. Or you know that you, let's say it's the other way around, the user is like selling ETH and getting USDC. So you know that in a week you will have some ETH unlocked. So for a week we have exposure, but you can be smart and be like, I will buy a put option. I'll have the right to sell that ETH. Yeah. And then the price that the user will pay for, let's say that bridging operation is gas fees, plus, Black and Scholes, whatever is like the proper way to price it. So you see, for the user, it's getting really simple. But the solvers, they are the guys doing like the fancy operations.
Yeah. Okay, then, so answering my question, the oracle is the storage proof that
Yes.
is already inside of the blockchain
Yes.
because of the layer 1, layer 2 thing.
Mhm.
And do you have a take on if you prefer optimistic, longer finality layer 2s or to zero knowledge one? Like, do you have an opinion on that? Or what
Zero knowledge, because like, well, what's gonna be cheaper? Nowadays, proof generation is getting really cheap. And if we have like a lot of like, economic activity on an optimistic product, let's say bridging, let's assume that people want to do it trustlessly, what's gonna be more expensive? Generate the proof or hedge that much money? The cost of hedging is like way higher, right? So ZK all the way and fast settlement. Okay, so if there are no more questions or questions from the online audience, I think I'm gonna call it a night. Thank you.